In this video, we will explore 3 different types of calculations used in engineering applications. The first one is analytical, second one is numerical, and third one is statistical based analysis. First up, we have the analytical calculations. Analytical calculation refers to a mathematical method of solving equations or problems using explicit formulas or established mathematical techniques. It involves deriving precise and exact solutions by manipulating these symbols and equation based on known mathematical principles. So we have one equation or multiple equations in which we connect them to each other. For example, if we want to calculate the hydraulic pressure at the receiving end of a simple hydraulic system, we use analytical based calculation. Or if we want to calculate the resistance of a wire, we also can use analytical calculations. And these methods are very much used in industry for such simple calculations. And the actual accuracy of these methods is quite high. So we only use analytical calculations when we have a problem that is simple enough to be modeled as analytical based calculation. Sometimes the problem can be too complex to be modeled in analytical equations. For that, finding an exact solution becomes a daunting task. Fear not, numerical calculation comes to the rescue. Numerical calculation involves solving mathematical problems or equations using numerical methods and algorithms. It relies on approximations and computational techniques that many times sectioning up the calculation domain into small pieces to be calculated one by one. Examples of numerical calculations that are actually used in industry are computational fluid dynamics, CFD, for computing or simulating the fluid dynamics problems. Another example for calculating stress and strains experienced by a machine, we often use the finite element analysis, FEM. In general, numerical computations works well, and it is quite well established in engineering companies. However, many times its accuracy does not match the real world. The real world machines' operational conditions are quite dirty, and it's not exactly going to match the simulation environment. On the other hand, the geometry in the computational environment is very clean and perfect, and in the actual world, such geometry is not as perfect and clean as the simulation environment. To simulate the general effect of an environment on a machine, such as calculating the lifespan of a machine or predicting the next maintenance service session date, it is recommended to use statistical based calculation. Statistical based calculation involves applying statistical methods to analyze data and draw conclusions. It includes various techniques such as evaluating the data central tendency, such as calculating the mean of the data or the median of the data, and measure of dispersion, such as calculating the data variance or standard deviations or standard deviation value. It also needs hypothesis testing, regression analysis to gain insight into the data. We need these models or statistical calculations to build the models to predict the value of interest. For example, calculating, as we said, the life span of a machine, or when the machine will need the next maintenance session. In general, statistical calculations are becoming more and more common as IoT devices are also increasing. Such devices will generate more data, and statistical based models will and can use this data for its own analysis and modeling. Future engineers will require to know and to use analytical, numerical, and statistical-based calculations. In the future, what we are most likely to see is the integration of statistical calculation into numerical calculation, and also integrating analytical calculation into the models of statistical calculations. So all these methods going to be used in the future